Hello all, good afternoon everyone. My name is Arijit. I started my career as an architect, not a technical architecture, but design architecture, designing buildings, spaces, interiors, and then I transitioned to designing digital products. Today I'm going to talk about a field that I have been very deeply passionate about, and I feel that this is really a combination of space design and digital design, and that is spatial computing, or more commonly known as augmented reality, virtual reality, or extended reality, which is the umbrella term of AR and VR. Now, to really understand this technology, we need to retrospect who we are as humans and what is our relationship with technology. And today I'm going to talk about some of the most chronic problems that we have been facing in this technology. Today you are listening to this talk under emerging technology track, right? But this technology has been with us for more than 20 years right now. It is still an emerging technology, partly because it's not become mainstream yet. We don't use it in our everyday lives yet. And today I'm going to talk about what are the kind of experiences we have built so far in this domain, what are the kind of experiences that we should be building, and what is the role of design to truly make this technology mainstream, to truly let the mass consumers adopt this technology and understand this technology. So I'm going to talk in detail about this, but first I want to start with a story. The story of Flatland. Has any of you here heard the name Flatland? A show of hands? Great. So 2 hands, awesome. So Flatland is a story about 2D civilization. A civilization that exists on a 2D plane like this paper, like very flat. And the citizens of this particular civilization are denoted by squares, rectangles, circles, even lines. So one day, I don't know why this is happening. Yeah, so something wrong? It's going to the next screen always. Okay, so one day there was this one spear like this ball who came to this flatland, and there was this interaction between this square and this 2D square, this spear and this 2D square, and the conversation happened where the square was talking about spaceland, which is the third dimension. So the square says, what is really spaceland or a third dimension? The square says, just like in your world, you can move forward, backward, right, and left. In our world, we can also move upward and downward. So the square was absolutely fascinated by this concept. He said, can you show me? So the spear took the square out of this plane of existence, gave him a tour of the entire spaceland, which is the 3D dimension, and then returned him back to the flatland. Now, upon returning, the square's life completely changed. It was a transformational experience for the square. He saw a third dimension, a higher dimension, and he started preaching about the third dimension to other creatures in the flatland. And nobody believed him. And later he was sent to jail for preaching too much about the third dimension. So this is a very small part of, and a very significant part of the whole book. And this book was written by Edwin Abbott in the 19th century. Imagine the kind of imagination they had back then. But there are two key takeaways I want to have from this story. So let's talk about the first one. Yeah. Oops. Okay, thank you. So let's talk about the first one. What does it really mean for something to be in 2D and then come to 3D? We all are 3D creatures, right? We perceive everything in 3D. We live, we eat, we survive, we connect, we communicate, we do everything in third dimension. But there is another life that we have been living for the last 15 years that has almost become a second life for ourselves. It is almost as important as our physical life. And this life is really powered by these particular devices. We all have them, right? Every one of us have it. We have laptops, we have tablets, we have smartphones, And even if I get rid of this particular phone, I can buy another one and I can start where I left off. So it's really the apps, the softwares, the experiences, the products, and the services we use inside these devices that makes up this life. And very simply, I call this our digital life. So in our digital life, we work, we play, we communicate, we connect, we create. Our professional and personal lives have digital versions of themselves. Who would have thought 15 years ago the kind of impact a digital life has on our physical life right now? But there is a small problem. Well, not really a problem for the lack of a better word. It's really like an opportunity in disguise. It's similar to what, if I go back in time, what candlelight was to light bulb, what horses were to cars, what keypad-based smartphones were to multi-touch smartphones. We really didn't want them. These are very important inventions, right? But we really didn't want them. Except when we had them, there was no going back to the older solution. Like when we had iPhones, when we had the experience of iPhones, there was no going back to the Blackberries and Nokias. Once we had cars, there was no going back to the horses. Once we had light bulb, there was no going back to candlelight. So a similar problem exists with our digital life right now, and that it exists in 2D. It exists in these 2D surfaces, and for the first takeaway of the flatland story, just like how the square traveled from the 2D plane to the third dimension, now the question is, can our digital experiences go beyond the 2D screens? Can our digital experiences move from screens to spaces? That's the key question that I'm asking over here. And this is where spatial computing comes in place. So spatial computing is a very broad term. AR, VR, XR is already a part of it, but there are other nuances in this technology that are also not very popular, like very projection-based technologies, where you see in museums, there are projection-based projections on the ground, and it reacts according to your movement. Then there is audio-based computing as well. Then there is sensory computing, where computers can actually recreate senses like taste and smell. And then there is autonomous vehicles as well, where using LiDAR technology, it informs about the surroundings of the car, and the car navigates according to that. But my focus is really on AR, VR, and XR, most particularly the wearable headset-based computing experience. We all know what is the form factor right now, right? It's a bulky looking piece of hardware, and it will slowly go down to this future where it's looking like a normal regular glass. So I'm not particularly focusing on the hardware aspect. We're going to talk about the software. And to really understand the software, this is one of the most cleanest explanation of what is AR, what is VR, what is MR, what is XR, is what I really believe. So you start from reality, and then you see augmented reality, which is really bringing digital components into a space. And then you have augmented virtuality, which is a bit more digital components in your space. And then there is virtual reality, where you are completely detached from your physical life, where you are completely transported to another digital virtual world altogether. And what are the great promises of spatial computing? So, speaking about accessibility, equity, ergonomic, and expediting learning, these are some of the greatest promises of spatial computing that we have. And we have heard a, a number of times that what it can do. In accessibility, I can safely say the spatial computers in future can be the most accessible computers, not only headsets and spatial computers, the most accessible computers that we can have. Because imagine this, you can interact with your digital component just by your movement of your eyes and your two fingers. It will eventually replace the mouse altogether. So imagine people with limited movement can just interact with computers with eyes and their hands, which was not possible before. Really a controller-free experience where we are moving into right now. Equity. Technology has played a great living playing field so far, and XR, one of the technologies, is not an exception. Imagine a visually challenged person who is wearing a spatial computer can easily navigate with a spatial computer with the directions given by an AI. Ergonomic, this is one point that very few people talk about, but I want to highlight that this is one of the most ergonomical computers as well, which is literally freeing you from the desk and the chairs experience. You can take this computer anywhere with the big screens, and you can have a computing experience in any posture, even while you are while in a sleeping posture. Even that is possible. And expediting learning, we all know what the impact it had on education and training. Because you can see everything in 3D, learnings become much more faster. So expediting learning is another one of the great promises of spatial computing. What are some of the existing ones that we have right now? As I spoke about, I'll talk about some of the existing ones as well, where we have some of the web AR-based experience where you don't have to download an app, you can just have a camera-based experience, and mostly used for digital marketing and used by many brands. And then we have a famous example of Amazon, where 2D images are no longer enough to make a good buying decision, where you have to see the products that you are buying in 3D in your space. And then there is navigation, one of the classic example of camera-based navigation, where you can see overlaid directions into streets, and there are outdoor and indoor-based navigations as well. And these are some of the most specific use cases that we had built so far in XR experience. Surgery-based experiences as well. For the doctors who use it as a surgery assistant, then we have remote assistance where the experience can actually help you debug complex machines and wiring systems. And then, as I spoke earlier about training and education, VR is essentially used for that. And obviously gaming, health and fitness, right, which has so far dominated this industry. But are they enough? Are they enough to really bring the mass consumers to adopt this technology? So far, the question is no, right? These experiences that has been built so far are very specific. It is not for the mass consumers yet. So we require change in approach. We require change in our mindset. So the change that I'm proposing here is really in two folds. The first change that I'm going to talk about is the fundamental approach in how we identify the right experiences we should build, and then how to design the core experience. So first change, the fundamental approach to identify and build the right experience. So far, this is what our mindset has been, right? It's headset. Now, if we really see them as computers, the whole thing changes, right? Just like we have our smartphones, we have our laptops, we have our tablets. These are all computing devices, right? We should see these XR headsets as computers. And so far, we had looked into XR fit problems. We always asked our customers that, okay, what is it that really you think that can be really solved by XR? And based on that, we have solutions like that. So this approach still needs to exist, right? It'll still be there. But the another approach that I'm proposing that we should have going forward is how do we redesign existing application into spatial application? Very simple, starting from the basic. Just like you design a responsive application for a smartphone, for a tablet, for a laptop, how do you redesign the same experience for a spatial computer? And a lot of people have asked this for many, many years, that what are the real killer apps for AR and VR? For me, killer apps for AR, VR already exist. It exists in 2D screens, and it has not been built for 3D spaces yet. So the question really here is, these existing apps that makes up our digital life, are they better usable and are they better useful when used on a spatial computer? And what if the experience, now this is very important, this is where I want to draw your attention as well. What if the experience of using the apps in a spatial computer is so good that there is no going back to using it in 2D screens? Can it be done? So now really, how do we design them? How do we really design the core experience? We don't have to be a designer for this right now. We all can have this mindset and going forward. So the change too is how that I want to bring it forth here, rethink how we can design the core experience. So far, we have been imagining too much. Like we have been recreating the physical life into digital life, and sometimes it feels very gimmicky, right? Sometimes right now, to rethink the approach, we need to take a step back and see, yeah, and see what is it all about to design the core experience? Now, this is where the second takeaway from the flatland story comes in. The second takeaway is all about emotions. Designing the core experience is all about emotions. Just like when the square traveled from the spaceland to flatland, it went through a transformational experience. But he also felt very overwhelmed, right? Because it was completely new for him. We have similar feelings because we are also 3D creatures, but we are wired to perceive digital experiences in 2D. And it is by design. Nobody questioned that, right? So when we have these, uh, uh, these digital experiences going beyond this plane of existence, we have similar feelings. Even we have much more feelings like we sometimes feel overwhelmed, sometimes we feel underwhelmed, sometimes we feel this experience is very gimmicky, but none of those experiences really stay with you. They don't stick with you. You really don't go back at home and say that, hey, I want to do that again. I want to have that experience again. You don't really say that, right? So now the time is to take a step back and really understand this technology's nuances. So far, we have been building experiences either on AR or for VR. Sometimes also mixed reality experience where it's combining both. But the change in approach that we need to have is that every spatial experience can be both AR and VR. Very simply, it is all about immersion. How immersed do you want your users to be in your experience? These jargons like AR, VR, XR, if I eliminate that and really see this spectrum as a spectrum of immersion, then the whole thing changes. The whole mindset of how we design this experience changes. So very simply, if I see rethink this whole spectrum, it will be more presence to more immersion. Forget about AR, VR, and XR. Every experience in future, because the spatial computers are going to be so powerful, the users have the choice to switch between AR and VR, and it's on the users that how much immersed they want to be. And this is really inspired from the Apple design principles as well. And today I'm building on top of that. So if I really break these immersion levels, it starts from level 1, where it's all about smartphone-based AR experiences, where you are still grounded to reality. But level 2 is where you start with a spatial computer, with a wearable headset, where you are actually using a headset. So in level 2, the apps can be window-based. In level 3, it is more immersion, where it's not only window, but also 3D components. And in level 4, it is complete immersion, where you are completely surrounded by digital experiences. And today I want to bring another vertical lane into this. So this is a lane of space. This is a lane of context. Without spaces, there is no spatial computing, right? So at the top, we have context independent. At the bottom is context dependent. What is context independent? Let's say you are using any application and it doesn't matter which space you are in. And let's say you are using an AR application that is really that is tied to a particular space. So let's say when you go to a museum and you are seeing an augmented reality experience, it is really about that museum, right? And then there are context independent application that you can use regardless where you are. But the reality is that everybody doesn't have the same space. Everybody's context is not different. We want it to be more free. We want it to be more flexible. So, being talking about flexibility, there's another. If I split this entire vertical spectrum into three parts: context independent, dependent. There's this one that is coming in the middle, which is context adaptive. How your experience, a digital experience, can adapt to your existing space. That is the beauty over here. And this is a spatial experience framework. Every experience that has been designed so far can fit into this framework. Every experience that we can design for our customers, we can pick and choose from this particular framework. And today I'm going to focus only on this part, which is context independent and context adaptive experience, level 2, level 3, level 4. And this is where spatial interface design comes in. This is the beginning of spatial interface design. We have been asking what are the kind of design that can go into this kind of experiences. This is where spatial interface design has a beginning over here. It's really about context independent level 2, level 3, and level 4 experience. And the fundamental of it is if I say the transition between the immersion levels has to be subtle and seamless, just like the 2D square went from one space to another space and was completely overwhelmed, when we move from one dimension to another dimension, or we move from one level of immersion to another level of immersion, the transition has to be very subtle and seamless. User should have the control to transit between the immersion levels. If we drop our users directly to a particular world, they will feel disoriented. I myself have motion sickness, so I myself get very icky when we use these experiences. So user has to have that choice. Every spatial computing can be both AR and VR, as I spoke about the seamless transition between the immersion spaces, and then thinking from the basic UI design principles, right? How do you build an experience for smartphone, then for tablet, then for laptop? How do you redesign that for a spatial computer? And I'm going to give some some demo. Before that, uh, there are some questions that comes to our mind always when we see augmented reality in very big screens. Is it all about replacing the monitors? Is it all about just making the existing app UI larger when used in a spatial computer? Well, no, it can be more than that. And if I really break these immersion levels, it can take really several forms. As I said, that these immersion levels can transition from one level to one another, and it can be just one experience. So let me give you some examples. I've taken a stab into how we can redesign some of the existing apps and experiences that we use every day. Can we start about the demo? Yes, redesigning Excel and spreadsheet. Now, you would think, why on earth would I use Excel and spreadsheet in augmented reality? So the question here again is, oops. So the question here again is, if you use it in augmented reality, can it be more usable? Can it be more flexible? And when you use it in augmented reality or in a spatial computer, do you really want to use it back in a 2D screen? That is the question. So we all know the problem, or let's say the opportunity in disguise, as I spoke earlier, right? Excel sheets can be very extensive. You move from left to right to see the full extent of the file, right? And what you do right now, you scroll from left to right, you go back and forth, and also from top to bottom. Now, if I think of how we can redesign these experiences, the first step that I want to have is that how do we view these apps in a spatial computer, and how we navigate between these particular apps and experiences. So when you see it in a spatial computer, first you are in this beautiful looking living room, and you are wearing a spatial computer, and the first thing you see is reality, right? And then you launch Excel sheet. And the first time when you launch an Excel sheet, this is how it looks like. Exactly like how you see in 2D screen. Remember, the users have to have the choice when they want to transition from one level to another. And the magic lies over here when you use it in a spatial computer in the bottom part, which is a particular button called expand. And when you click on it, this is how it expands itself. We have never seen Excel sheet like this in any 2D screen before, where we can see the entire extent of the file. And we don't even have to navigate from one end to the other. We don't even have to scroll, right? So with the movement of your head and eyes, you can navigate throughout the whole Excel sheet. And this is also true for applications like video editing tools, where there is a timeline at the bottom. If you have edited videos in it and using any software, you always have to zoom in and zoom out and scroll back and forth between these the timelines. So when you stretch that and expand that particular UI, that problem actually gets solved. So I'm not prescribing this is how Excel should be redesigned, but this on a very conceptual, graphical user interface level, that how we can rethink these experiences on spatial computer. And the next app that I'm going to talk about is something that we use every day. Zoom, Teams, Google Meet, right? So this is how it actually looks in existing UI format. There is a screen share that is going on in the middle, and then there are the section of the participants where sometimes you do have no idea how many people are there. You have to scroll down and bottom, this endless navigation things that you have to do. And then the more pain point is when you have this chat window popping up all the time, right? You always have to switch between these particular UI components, and it's all happening within that particular box. What happens when it completely goes out of the 2D screen? What happens when it's no longer restricted by that particular rectangular surface? So when you really use it in a spatial computer, you can see there is the same UI. You can also notice there's a shadow at the bottom, and it can really make you feel like that is part of the whole space. So there's an interplay of light and shadow that we can add to the design as well. This how is actually looking existing in the spatial computer, exactly how it looks like in a 2D screen. But when you use it, really use it for a spatial computer, you can see all the windows are there on your side always. You can see who is speaking, and there's a small touch of using the depths as well to highlight who is speaking. And then there's a chat window that is always present, so you don't have to always click on it and open it and close it, and then again do the same thing all over and again. So these windows are always there with you, and then you are fully focused and concentrated on the screen sharing that is happening on the middle, which is the primary focus of the meeting that is going on. And let's say you are actually working on with your colleagues on this particular building project, right? And this is really a 3D model. So how you can transition from level 2 to level 3 is like this. That 3D model can come into your space, and you can also interact with the 3D model while it's happening in your space itself. So you can rotate, you can navigate within this particular building in your space itself. And now let's say you want to go inside that building. So there's a particular streaming going on, right, on a 2D screen. But this can also transition to level 3, where there is more, right? Where it can be actually like a portal kind of an experience where you are going inside that portal. Or there is something more. Let's say you are seated, you really don't want to walk, you want to sit it on a place, and you want to completely immerse yourself with that. The same thing can happen just by click of a button. It can transition your experience to a level 4 experience, and you can get completely immersed by this digital element. You can go inside with just the click of a button. So this is how you can go back as well, and the user can actually have the choice between how much immersed they want to be. And the last experience, the last application that I want to focus on, which is one of my personal favorite, and it's an application that is in 2D but is really dying to come to in 3D, and that is Google Earth. So when you open it on a spatial computer, this can be the landing page. And when you click on start, it can directly start with a level 3 experience. The Earth can come to your space, and you can navigate exactly how you exactly currently navigate in the 2D UI application. So the Earth can actually be in your space, and you can do all other things that you currently do in existing Google Earth application. So these are some of the examples that is just some of the glimpses, ideas that how we can really redesign existing application. You don't have to have other n number of applications that we can think of, just how we can purely focus on redesigning existing application for a spatial computer. Can you go back to the presentation? Right. So the few challenges still remain, right? The challenges like social isolation and privacy concern. Like social isolation, uh, you always think that when you wear that headset, you are completely isolated, right? But this is also a design problem that can be solved. Like what Apple Vision Pro is doing, you can actually see the user's eye, so you can make eye contact. You are not completely isolated from where you are. It's a natural part of your environment. It's like a natural way of computing. Then there's privacy concerns. When we design an experience, there are more concerns that are going to come up, where how much camera data do I need to give uh, uh, to the to the app, to the third-party application. So this is something that can also be solved by restricting some of the camera feed to the third-party applications. Now, what Apple Vision Pro is doing on this is that it's restricting the camera feed, but it's also giving, using LiDAR technology, it can actually have point-based terrain kind of a outlook rather than image kind of an outlook. So when you're sharing your information of the space, all the third-party application needs is just points and not images. And then there's hardware form factor that I spoke about, which eventually are going to be in the glasses form factor. And then it's not an economical technology to adopt it. So we know how technology has progressed. It starts with a very costly scenario, and then slowly as we adopt it, the technology cost reduces. And then if you see this image on the side, it's completely filled with digital elements. We don't want this future. Augmented reality can't be better than reality. It has to complement the reality. So we have to make very careful design choices when we design this kind of experiences. We don't want this particular dystopian future. So what are the key takeaways from this? Digital experiences moving from 2D screens to 3D spaces. Exactly how we build for smartphones, for laptops, how can we build it for spatial computer? How can we build responsive and adaptive experiences? XR apps can be transient experiences. As I said, it can be both AR and VR depending on the user's choice. And also the spatial experience framework can actually guide you what are the experiences that we can build for our customers or any new experience that we can design in the future. Haptics, sound, and motion design is equally important. As you saw in the demo, the transition between one level to another level was really on the motion design, how swift the transition was happening. So motion design, sound, and haptics feedback is very important to consider when we design these experiences. And lastly, spatial computing as a new field of technological creativity and innovation. We know that 2D design and development has reached a stagnation point where you can just ask an AI for a design mockup, it will generate one, right? But can it create a spatial UI? Well, not yet, because a lot of possibilities have not been explored yet. And some people ask that where does really AI fit into this picture? Now, I will say that AI is really baked into everything, right? And you still need a computer to run AI or Gen AI. Spatial computing is a whole new way of how you interact with the computer altogether. And 15 years ago, there was a movie called Iron Man, where whenever we think of augmented reality, we see Tony Stark interacting with all those screens, spatial screens. But we also forget about Jarvis, who was an AI, right? Who was an AI assistant of Tony Stark. So 15 years ago, somebody had already imagined what a combination of spatial computing and AI can look like together. So today, it is my humble urge to everyone here, technologists, designers, and developers alike, that while we have AI, with the combination of AI, these experiences can be really powerful. And and at the same time, the problems that we have with AI is that AI is hallucinating. So while AI is hallucinating, we humans should start dreaming about creating these new age experiences. And with that, I conclude my talk. Thank you.